Well, hello, 2.7, absolute value functions and graphs. We're going to start off by taking a look at a couple key concepts here for absolute value functions. And if you want to take a look at a real quick uh, graph here of what absolute value looks like, this is just kind of like a little makeshift graph. Recall that the absolute value function is very similar to what they call a V-shaped graph. So it looks something like this. In that V-shaped graph, today we're going to learn how to shift that up, down, left, right, and then apply a stretch or compression to these functions here. And also be able to identify the vertex of an absolute value and also its slope. So let's take a look here at some general concepts. Here is your parent function. And remember, when you're translating in a vertical fashion, that your k value will dictate the vertical. Plus k you go up, minus k you go down. A horizontal translation is your h value, in this case inside the absolute value function. Negative h means you're going to go to the right, and plus h means you're going to the left. It's kind of opposite of what you think it should do. A stretch or compression, this is a stretch away from the x-axis, and that means that your a value is going to be greater than 1. So this would be a number such as, I don't know, y equals 3 times the absolute value of x. That would be a good example of a stretch. And a good example of a compression is where a is less than 1, but greater than 0. So it's probably going to be a fraction, something like, I don't know, y equals 1/3 the absolute value of x. Up here again for the vertical translation, a couple quick examples would probably be y equals absolute value of x plus 4, or you could have y equals the absolute value of x minus 6. Horizontal translation, again inside the absolute value. A good example might be y equals absolute value of x minus 1. And another example of a horizontal translation, absolute value of x plus 7. A reflection, on the other hand, is going to be taking into effect the opposite of the entire parent function or the opposite of x inside the parent function. If it's the opposite of the whole function, you're flipping it around the x-axis. An example of that might look like y equals negative x minus, I don't know, 4. Again, it has a vertical component, but this negative outside of it is going to translate into the reflection around the x-axis. Reflecting around the y-axis, you would simply have, you could have something like 2 absolute value of negative x plus 5. Again, as long as it's inside with the x, then it's going to be a reflection. Let's take a look at combining some of these translations. A bit of a multiple choice for us. Before we get here, I want to just review a quick concept here. This is your general form for the absolute value function. A great note for your Cornell notes. And A is your stretch or compression, H is your horizontal shift, and K represents your vertical shift. The neat thing about this general form is that it quickly allows us to take a look at the vertex HK. And the line of axis of symmetry is always x the line equals your h value. Now, what does that look like? Let's take a peek and find out. Down here, combining translations, I still have that y equals a absolute value of x minus h. Technical difficulties here. There we go. Plus k to look at. So here, my h value and my k value are right there. My h is going to equal, remember, take the opposite of it, and my k value, it is what it is. So if I wanted to write out the vertex of this, I'm going to have -2, 3. So all we need to do is to find one of these graphs that has a vertex at -2, 3. So this one has 2, -3. This one has -2, 3. This is a good option. This one is -2, or excuse me, +2, 3, and then a -2, -3. Well, A, C, B do not work. This one here, -3, excuse me, -2, that's our vertex. Our answer is going to be D. Let's take a look at a vertical stretch and compression. Just another quick reminder is that our general form is y equals a times the absolute value of x minus h plus k. And they're just asking about a stretch or a compression. Now remember, a stretch is where a is greater than 1, and a compression is where a is between 0 and 1. So let's take a look at this graph. Y equals 1/2 times the absolute value of x. It is going to be a compression towards the x-axis because it is less than 1 and greater than 0. So this here is our stretch. I'm sorry, our compression. Now, take a look at this function again. What are my h values and k values? Well, Mr. Bova, they don't have any. Well, that's very true, because you can rewrite this as 1/2 the absolute value of x. Get that little part right there. Absolute value of x minus 0 plus your k value of 0. Now you've just found the vertex, 0, 0. So I'm going to go right here and put my vertex in. This 1/2 is your compression, and it's also known as something we're very familiar with, slope. So I'm going to go to that point, go up 1 over 2, up 1 over 2, and keep repeating that process. And then I'm also going to do that over here. And a really good habit is to put in as many dots as you can, because on our later sections, it's going to be awfully handy. And there's our graph of y equals 1/2 absolute value of x. So those vertical stretches and compressions, remember, this is a stretch away from x-axis, and the compression is towards the x-axis. With this in mind, let's take a look at stretching and compressing a function. When you really stretch and compress, what you're doing is you're multiplying your y values by that stretch or compression. And here's what I mean. They give us a function f of x, and they said, hey, what are corresponding values of g of x for possible graphs for the transformation of 3 times whatever f of x is? Now, if you recall, f of x is the same thing as y. So what you're doing is multiplying 3 times all your y values for your f of x function. And again, here's what that looks like. Here's all your x's, all your outputs for that f of x. Multiply 3 times that f of x, because that is your compression, or excuse me, your stretch away from the x-axis. So you're going to multiply all your y values, f of x, times 3 and get your g of x values. In other words, if you were to draw another t-chart you'd have all your x values that you plugged in, and it would spit out all of your new g of x values because you multiplied the originals by 3. So far, so good. All right. Now let's take a look at reviewing some of these ideas again of vertical translations, horizontal translations, vertical stretches and compressions, and our good old reflections. Our K value is a vertical translation. Our H value is horizontal. Remember to take the opposite. Vertical stretches and compression, if it's greater than 1, it's going to be a stretch away from the x-axis. If it's between 1 and 0, it's going to be a compression towards the x-axis. Take the opposite of your entire function, reflect around the x-axis. Take the opposite of your x values, you spin around the y-axis. Again, a little bit more recap. HK is going to be your vertex. Whoops. Let's try this again. HK is going to be your vertex. And your axis of symmetry is going to be your line x equals the value of h. Now, vertex we probably understand. Axis of symmetry, we might need a little bit more of an idea of what that looks like. Here's an example. Just the parent function. Y equals absolute value of x. HK is going to be our 0, 0 point, because really that's going to be plus or minus 0 plus 0. That's going to vertex right there. And the axis of symmetry is just the line x equaling the value of h. Here's an example. Suppose I had y equals the absolute value of x minus 2 plus 4. My vertex is going to be the opposite of this, which is your h value, and 4. That's our vertex. Our axis of symmetry is going to be the equation x equals my h value, which is 2. Here's a little picture of what that might be. I would go to the vertex 2, 4, put my point right there, and then my axis of symmetry is going to be x equaling 2. Whoops. So I'm going to have to draw myself a little line here, and it's going to go right through. The vertex and the x-axis. And move that puppy over. I know we can do this. There we go. Right through the point and the x-axis. Again, that's the axis of symmetry. And if we were to finish off this graph of the absolute value, we would just be writing the parent function. But that's the idea of axis of symmetry. Cut your graph right in half. Sorry about that. Let's take a look at what the equation is of this absolute value function. First, identify your vertex, then your slope. Our vertex is 1, 4, and our slope, let's see here, we go down 1 over 3, down 1 over 3. That's a negative slope, so that's going to be negative 1/3. So now we just fill in the blank. Y equals our slope. And as you can tell, the period's over. And then x minus our h value, which is right here. And then we get to plug in our k value of plus 4. You guys get to figure this one out on your own, and I'll see you guys tomorrow.